So we've already talked about whether or not an argument is valid using the forms of valid arguments. So now we'll be able to evaluate the validity of an argument using forms of invalid arguments. So I have the fallacy of the converse. So if you don't mind just looking back at your notes when we had talked about the conditional, the converse, inverse, contrapositive, you'll notice that the conditional and the converse, those were not logically equivalent. Okay, so if something follows the form of a converse, we would know therefore that it cannot be logically equivalent, therefore not a valid argument. Okay, so we have if P then Q, and we start out with a Q then P, so that does not follow. So this would be considered an invalid argument. So they're saying if it's Saturday, then Laura will go to the mall. Laura is at the mall, therefore it's Saturday. So I think you could see logically how it's not valid. Laura could go to the mall other days too. So if it follows this form, that's a fallacy of the converse. Okay, and then we have the fallacy of the inverse. Same kind of idea. It's not logically equivalent to a conditional. So if P then not Q, well, we have not P, then we're saying it follows not Q. This is not valid either, so look at the example. If she buys a new dress, then she'll buy new shoes. She didn't buy new shoes, therefore she didn't buy a new dress. She could buy new shoes without buying a dress first, so that makes sense. That it doesn't make sense just logically when you think about it, and also we could use the common form. We know that the inverse is not logically equivalent to a conditional, so that would be the fallacy of the inverse. So the other one I want to add, I don't have it on your notes, is the fallacy of the inclusive. Okay, so you start off with P or Q. They're saying P happened. So they're saying if P happened, then Q could not have happened. I mean, that is not the case. Remember that we could, Q could also happen. One could happen, the other could happen, or both could happen. So clearly this is also going to be the same as P or Q. If Q happened, then saying not P. All right. So let's look at example 16, and let's determine the following arguments are valid by the given forms of valid arguments and the fallacies. So we're going to look at both things that we've learned in the last few pages. So if Tom doesn't get the job, so we'll say that's a negation of J, then he won't get in a car. So we'll say that's a negation of C. So Tom didn't get a new car, so that's the negation of C. Therefore, Tom didn't get the job, so negation of J. So I want to point out that these look exactly the same. So do these. We haven't changed one from being a not to the positive. So this to me looks like the fallacy of the converse. So therefore it would be not valid. So I know that's kind of hard to see because we're used to the if P then Q. Q happened, so therefore P happened. But if you'll look at that, it does follow the same form, okay? These look exactly the same. This is not the negation of this right here, and this is not the negation of this negation up here, okay? So it does follow the form of the fallacy of the converse. All right, let's look at B. If she fails the exam, and I know this sounds weird, we're going to think of failing as a positive. Then she'll get an F in the class. Okay, I guess I'll put a capital F there. And it says if she gets an F in a class, put a capital F, then she won't graduate. So we'll do the negation of G. Therefore, if she fails a class, then she won't fails the exam rather, then she won't graduate. Okay, so finally we have a good example of the law of syllogism. Okay, so it looks like a little bit like the transitive property, doesn't it? Okay, so this would be valid because of the law of syllogism. Okay, so how would you figure that out on an exam? Well, you see that we have two if-then statements, okay? And these are exactly the same, so we should follow up with if F, then whatever that was right there. Okay, so if there is no cereal, so we'll say the negation of C, then Ellie will have oatmeal for breakfast, then O. Ellie didn't have oatmeal for breakfast, so that's a negation of O there. Therefore, there was cereal, so we're going to say C. Okay, so it looks like we have the opposite of what happened here, and we end up with the opposite of what followed our if statement, okay? All right, so that to me looks like it's going to be valid because of the law of contraposition. Okay, let's look at that again. Remember, if we had if P then Q, then we had a not Q, therefore not P, okay? So again, we had a negation of what follows the then, and then we would have the negation of what follows the if, and that's exactly what we had. The negation of C would be C. All right, let's look at D. I'll either walk or ride my bike to the library. So walk or bike. I couldn't ride my bike, so the negation of B, don't care why. Therefore, I walked to the library. Okay, so they're saying if you didn't do one, you perhaps did the other, okay? So that to me looks like it's valid because of the law of disjunctive syllogism. So that one's pretty straightforward. They're saying either this or this happened. Okay, well that didn't happen. Therefore the other thing had to happen. Okay, let's look at E. It says if it's raining, let's use R for raining, Megan will take an umbrella. Therefore she'll take an umbrella. It's not raining. Therefore Megan didn't take an umbrella. Okay, it seems to me that they're trying to say that a conditional and its inverse are valid, and that's not true. We know that they are not logically equivalent. So we're going to say that this is not valid because of fallacy of the inverse. Okay, lastly, if class was canceled, then Nate will sleep in. There was a water main break, so class was canceled. All right, I don't really care why. Therefore, Nate slept in. This is our very first example of what a law of detachment looks like, so this will be valid. Again, law of detachment.